All right, today, guys, this is our last factoring thing, and it's really simple. It's really easy because there's a nice little pattern to it. There's no guessing, checking, anything like that. It's just you're looking for the perfect squares, you know. So like 1, 4, 9, 16, 25. Those are perfect squares because the square root of each is 1, and then the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, etc., right? So we're going to have numbers that look like that. The thing that's slightly different is that there's no middle term. You know, we've been dealing with like x squared plus 7x plus 12, right? Well, now that's not going to be there. And it's always going to be minus. We're going to have like x squared minus 16 or x squared minus 25. It's a difference because it's always minus, okay? So a sum of squares is not factorable. Okay, if I have a plus sign here, it's not factorable. So we're not going to worry about that. We're only going to do difference of squares. Now, why do we call it a difference of squares? Because they're both perfect squares. This is a perfect square. X squared. The square root of x squared is x, right? Okay, the square root of 16 is 4. And so how they factor these, you just make two parentheses, and then you take the square root of the first term and the square root of the last term, and you have a plus and a minus. Because really what we're saying here is we've got x squared plus 0x minus 16. These are the same thing. And to get 0 for that middle term, if I was going to use the x, I'd have to have 4 and negative 4 to give me this 0, wouldn't I? Okay, so that's why you have to have one of each sign so that that middle term disappears, because there's no middle term here. So the same thing here. I'm going to take the square root of x squared is x. So the square root of 25 is 5. And I have 1 plus and 1 minus. And it doesn't matter, I could write it x minus 5, x plus 5. The order of the two parentheses is not important. Okay, but that's how a difference of squares works. You recognize that it's a difference of squares. So if it's not a difference of squares, say it's x squared minus 6. That doesn't work. I can't factor that. There's no way. That ain't happening, okay? But as soon as I go x squared minus 9, well, that's x plus 3 and x minus 3. If I had x squared minus 49, that's x plus 7, x minus 7, the square root of each term. Okay? Now, what if you get something that's not a difference of squares, but maybe could become a difference of squares? Okay? That's not a difference of squares by any means, right? But can we factor anything? I mean, our idea is here's to factor, so can we factor something out? Oh, well, I can pull out a 2. If I pull out a 2, that leaves me with that, right? If I divide each of those terms by 2, 2x squared divided by 2 is x squared. 18 divided by 2 is 9. Now we have a difference of squares. So I have to have the 2 still, but I just factor the rest. So now there's 3 factors. Okay, and I have to list them all. When I'm listing factors, I have to list them all. So if you get something like this, pull the greatest common factor out. Let's say we got 4x squared minus, I don't know, 36. Okay, can I pull a 4 out? Yes, I can. And now I got 4, and then I got x plus 3 and x minus 3. Now, some of you might have said, hey, that's a difference of squares as it is, because this is a perfect square, isn't it? And this is a perfect square. So we could have gone 2x and 2x, and then the square root of 36 is 6. But do you notice something? There's still a 2 in each of these, isn't there? So I can pull that 2 out. And if I pull a 2 out of there, I got x minus 3. And so what's 2 times 2? 4. Okay? So at some point, you know, this one here, yeah, it's a difference of squares as it is. This is still a difference of squares. But if there's something I can pull out, I still want to do that first. Always. Because then if I don't, I have to do it here, and I have to remember that I had to do it twice, and so I need this 4. So a lot of people would write 2x plus 3, x minus 3, and they would forget that they had to pull a 2 out of the other one as well. Okay, so you want to pull out anything that you can first. Pull that 4 out first. All right, so let's look at another one like that. Let's say we got 9x squared minus 49. Okay, is there anything I can pull out? I can't pull out a 3. I can't pull out a 9. So here we are. So it's a difference of squares, though. This is a perfect square. This is a perfect square. So 3x and 3x. And the square root of 49 is 7. And I got a plus and a minus. And away we go. Now, another thing. The great thing about exponents is the square root of an even. Every even exponent is a perfect square. So like we just said, x squared, the square root of that is x, right? But what about x to the 4th? Well, that's x squared. Because of the exponent property, x squared times x squared is x to the 4th, because we add these up. So any even is a perfect square. So x to the 6th, the square root of that would be x cubed. The square root of x to the 8th would be x to the 4th, okay? And you can also go back to the idea that we used to have where we did this. I'm supposed to multiply these exponents, right? Well, 4 times a half is x squared. And I think we talked about this. X to the 1/2 is the same as the square root of x. I'm pretty certain we talked about that. Okay? But that's that property there. So now if we get something like this, let's say we got 4x to the 4th minus 25. So I could go 2x squared and 2x squared. And then the square root of 25 is 5. And there we go. And then again, once you get to here, you need to check to see if is it still a difference of squares? Is there something I can factor out? And in this case, there's not. Okay. But, maybe, see if I can come up with one here. Oops, I want a 4 there. Okay, so now these are both perfect squares. So if I factor that, I'm going to have x squared and x squared. Then I'm going to have plus 4 and minus 4. Well, is one of those a difference of squares? This one's not because it's plus. But is this one a difference of squares? Yes, it is. So now I'm going to rewrite the first one. And now I got the square root of x squared is x, and the square root of 4 is 2. And I got a plus and minus. Okay? So when you get done, you just have to check to see if there's something you can still pull out, factor out, or is something still a difference of squares. Okay? And so this has 3 factors. This particular thing here has 3 different factors to get to it. All right, let me know if you have questions. I'll put up a check probably this afternoon or tomorrow morning. I'm not sure yet. I still need to put up a quiz for Monday stuff. So just so you can practice if you need to. Have a good day, guys.